thank you very much for Tata Steel to inviting me and giving this opportunity to share whatever we have done at National Council for Cement and Building Materials, Ballabgarh. So I am not covering the fly ash part, combustion product. So my another colleague Brajesh Singh will be covering whatever we have done in that area. I am covering the only iron and steel slag, both. So my agenda of the presentation will be, as everybody starts with background, I will also start with the background. So context and background. Then current status of utilization of iron slag with vis-a-vis standards available at BIS level. And then I will discuss research projects undertaken by NCCBM. And what are those research projects will be discussed? We have done some research projects with Tata Steel, so these two, and then ferrochrome slag with the Tata Steel and Vedanta also. Ferrochrome slag is also the slag from allied industries. Then LD slag utilization, JSW cement, then granulated blast furnace slag with JSW, then studies on GGBS based geopolymer concrete again with JSW, and we are doing the EAF slag and Konark slag with ArcelorMittal Nippon Steel Limited. So these are the the background is increasing population, rapid urbanization, and GDP expected to increase from this to this by 2050. So larger scale infrastructure development, then increased demand for cement, concrete, and steel so. And therefore, increased industrial process for production, not only steel, but cement, concrete, and steel all together. Other allied, like copper slag and all that. So we can see the high demand scenario and low demand scenario. The high demand scenario near about 1200 metric ton by 2050. So 1200 metric ton means we can assume that 4 times or 5 times of aggregate needed. So 5 times of aggregate means we can see 60 million ton of aggregates will be needed. And likewise, the CO2 emission we can see. Steel production, world production, and very soon the India will be surpassing even USA and will become the second largest steel producer. And this is the data from World Economic Forum. Crude steel capacity in India will increase from a current level of 142 million ton right now to the 245 million ton by 2030 and 522 million ton per annum by 2050. So how much slag, how much LD slag, how much BF slag, how much LF slag, and how much aggregate and how much cement we need, we can see that. And 2050 will be the peak for the steel consumption for India, it is estimated. And you can see, but the technology will not be the same throughout. So one of the world steel production by technology baseline scenario, we can see the technology of steel production will also be changing because of the decarbonization, sometimes circularity, sometimes your lime content, sometimes combined effect of all these things to innovate. The technology will also be changing. So whatever we are discussing, the chemistry, mineralogy, and morphology, and microstructure, that will have to be changing. And any research project should continue. It will not be static at any point of time. So as a researcher, we will have to see that what changes are going on, and standards are also dynamic in nature. So standards, whatever today, will not be applicable after 10 years. So it will have to be, like I can give you an example. So people are discussing right from the morning that fly ash has this characteristic, this fineness. But I have collected at least from 10 to 12 plants of NTPC, and today no plant is producing the fly ash having 320 meter per square meter square per kg fineness. How the construction industry is using that, I do not know. Cement, it is okay, but concrete industry, I don't know how they are using it. So we have taken a project, what should be the specification of pliers right now. And today we do not have a sampling plan at BIS level. So what should be the sampling plan? Sampling plan is of 1973. And since then, the sampling plan has not changed. The production, the collection system of fly ash, collection system of bottom ash has quite significantly changed. But we do not have a sampling plan together right now, from where we should pick up the fly ash and we can analyze in the laboratory and we can say this is the representative properties of the fly ash. So the standards is also dynamic in nature. So slag is a broad term for any metal extraction industry. Slag is, the word slag is used. And we are going to discuss ferrous slag. But cooling process of slag and furnace type is responsible for generating different type of slag. And for the same process, the chemical composition can be same, but mineralogical composition can vary depending upon how we are cooling it. So this is a very, very important. And this is everyone knows, so most of the time the granulated blast furnace slag is being generated, but air-cooled furnace is getting generated lower by lower day by day because of the changes in technology. And expanded foam slag is also getting generated, and it can be used for a very, very well for lightweight aggregates-based concrete, which is also a demand of today. Sorry, previous slide. And steel slag, we can see BOF slag, EAF slag, and EIF slag, basically, from induction furnace slag. And this is the production of the slag. And we can see the 15% changes had taken place from over the years, in 1 year. And this is the generation of different kind of slags expected by 2030. So it is going to be 40 to 45 million ton of iron slag. And EAF and IF slag up to 10 million ton by the year 2030. And BOF slag up to 15 million ton by 2030. So we will have to utilize all these slags by 2030. And unless otherwise we will be researching and we will be having some policy, we cannot do that. Next. And these are the properties. So this is the slags obtained from various cement plants, Bhilai, Bokaro, Rourkela, Durgapur, RNL, Tata Steel, JSW, ISCO, and IDCOL. So these are the ranges. And ranges are sometimes, except AL203, these are in the almost in the same range. And these are the composition of steel slag. But for any kind of slag, for at least in the uses part, it can be used in cement and concrete, where concrete is concerned. It can be road construction, where the base and sub-base, where the concrete is not being used, that can be researched, and that is being investigated by CRRI. It is not in the area of concrete. So the concrete, altogether the two problems, the durability and the expansion, those are the most important things. It will have to be researched and it will have to be standardized in a different way. And other uses, Professor or scientist Bhupinder Singh has been discussed, agriculture and all that, so I am not going into that area. I will be discussing in this area. So sector-wise utilization, I am skipping it. So now, what is the present provisions in Indian standards for utilization of slag in construction sector, particularly in cement and concrete? So we have IS 12089, 1987, so a specification for BF slag for cement production, and in which glass content should not be 85%. We have a specification for ground granulated blast furnace slag, which can directly be used in concrete production, and it can also be used in PSC production as a blending material. So again, Glass content should be more than 85%. And here the slag activity index has also been mentioned. We have a ultra fine ground granulated blast furnace slag standards also. So one can follow it, one can produce it by grinding finer, and it can be used. It is a very, very good material. It can be in between the micro silica and the OPC cement or PPC cement. So this can be used for the blending purpose to produce a different kind of concrete. So now as an aggregate, so right now this is the scenario where the IS 383 provides the use of iron and steel slag. But these standards were made in 2016. And at that point of time, in my views, the committee which was responsible for making this standard was not aware of a different kind of iron slag. So iron slag from the EAF route and iron slag from BOF route and iron slag from induction furnace route has a different property. So at that point of time, the iron slag as a coarse aggregate and iron slag as a fine aggregate, it is okay. But for steel slag 25, nil and 100, this is being discussed right now. I am part of that. So it should be bifurcated. It has been agreed that BOF slag, no one is allowing in the absence of experimental research findings. So EAF slag, it is accepted. So very soon the amendment will be coming. Okay? And this steel slag will be bifurcated, EAF slag and BOF slag. So what should be done with the BOF slag? This is a question. So recent studies carried out by NCCBM for enhancing the scope of utilization of iron and steel slag. So these are the scenario which I have discussed. So studies on BF slag, studies on GGBS based geopolymer concrete. So I will not be discussing more about it. The people have discussed it, and this is being done with JSW. But I will be much discussing that not only producing the geopolymer concrete is important, how we will design the structure using the geopolymer concrete. Because the structural parameter, what should be the fracture energy? What should be the modulus of elasticity? What should be the bond strength? In the absence of those data, even if you are producing the concrete, how you will design the structure? Which value you will be taking for designing the structure using the geopolymer concrete, even if you are producing in the laboratory or in the plant or at site. So those research are very, very limited. So after developing and after having codal provisions on the geopolymer based standard for products, we are also working on what should be the structural design parameters for geopolymer concrete, which will pave the path for further use of this geopolymer concrete in the structure. So this is the geopolymer concrete. We have completed a project. I am not going into detail of it. What we have done, we have used the activators as the people are using it, and experimental pavement stretch has also been laid down, and it is being monitored. And based on that, a new standard in at our feedback, based on our research, IS 17452, a new standard has come up for use of alkali activated concrete for precast product, a guideline. So this has come. Recently this has come in 2020. So this is the new code, and experimental research was inaugurated by our then joint secretary, now he is additional secretary, DPIIT, Sri Anil Agrawalji. So as I said, the studies on mechanical durability properties of high strength geopolymer concrete is being investigated in our laboratory. So development of concrete in the laboratory using different combination of fly ash and slag is being done, and these properties are being investigated, and After completion of the project, very soon we will be submitting our report to the Bureau of Indian Standards, and it will be discussed, and then some structural design parameters will also be taken up in the standards. This is the a beam which we are studying for flexure behavior. So, for Tata Steel, we are investigating an activated GGBFS. As Dr. Chatterjee was saying, it can be activated at a dry state using the dry activators, and one can produce the zero OPC geopolymer cement, and Tata Steel has developed, and it is being investigated, and based on that, perhaps we will be able to say something about the specification, what it can be. So I am not disclosing anything because Tata Steel has also not disclosed so many things to us. So it's between the NCCBM and Tata Steel till the time a specification will be coming. So now the third project, granulated blast furnace slag as a fine aggregate. So why granulated blast furnace slag as a fine aggregate? One can ask, when it is being used as a cementitious material, then why it should be used as a aggregate altogether? So my answer is, we have seen how much production of steel is going to increase. And as for the cement producers, we do not have a very good limestone for production of clinker. So I hope steel producer will also not have a very good iron ore to produce the steel also. So the purity of iron ore, hematite, magnetite, whatever it is, will be a little bit of lesser quality, and the lesser quality of iron ore will generate more slags. And when it will be generated more slags, it may have less than 85% Vfass content, and what should be if it is a 65%, or if the volume is more, the pile-up will be at plant. So what it can be. And on another hand, we are scarce of sand, particularly aggregate particularly, so we can produce the sand. And perhaps JSW has taken this advantage. They have visualized in future visualization, we can say, congratulate to SMR Prasad. So they have established a plant at their Vijayanagar, and we have seen it. The characteristics of that sand which is coming out of that. So what is the difference between the granulated blast furnace slag and the sand produced out of that? So granulated blast furnace slag, one have seen, it's a needle type of structure. If we take in hand, it can penetrate in our hands. It cannot be used. On the other side, if it will be used directly as a sand, it will not be a good packing density. So it will not have a good packing density, then it will not produce a economical mix for concrete. So to have it, while going through the plant, it will have an angular shape. So having an angular shape, and it has a hard in comparison to the conventional aggregate, so it can be very well used as a fine aggregate. So, but we have seen that what is the percentage which has been allowed right now in Indian standard. So when it was being discussed in the IS 383 committee at BIS level, so people said that it can be used 100% or not. So gut feeling says that it can be used. So nothing will change when it will be used 100%. But research goes based on hypothesis. We test the null hypothesis, we test the alternate hypothesis. So we have some hypothesis, it will have to be tested, it will have to be experimented, it will have to be proved, then anyone will accept it. So hypothesis is being tested at our laboratory. So when it will be, we start from the null hypothesis, and if it will be proved wrong, so alternate hypothesis will be accepted, right? So it is being done by replacing the 0, 25, 50, 75 and 100%, and based on that, it can be recommended that it can be used up to 100%. So now a study on steel slag at NCCBM. So with Tata Steel, in PSC making. So in PSC making, we have made the composite cement, taking BF slag and mixing the LD slag. So taking 50% that kind of composite slag replacement and taking 60% of that kind of composite cement replacement in by making PSC. And studies says that in spite of the LD slag is having free lime in excess, it is not increasing the free lime percentage in cement, perhaps by the grinding, and perhaps by the grinding, it is the CO of free lime is not contributing. First, the dilution effect, and the second, because of the finer grind, it could have been production of the absorption of moisture in the air and converting it into the calcium hydroxide. So this report has been submitted to the Bureau of Indian Standard, and it is in the advanced stage of discussion. Cement industry has some observation, and perhaps those observations, again, the feedback from the cement industry will be discussed at BIS level, and then perhaps it will be through. I hope it will be through, but the cement industry, I mean to say, cement industry or construction industry or steel industry, we should not see altogether a different industry, because whatever is being done today, the circularity, sustainability, and climate change, the all industrial process and all industry should see this. So everything should be in the gambit of these three words: circularity, sustainability, and climate change. And one industry can be seen as a source, and another industry can be seen as a sink. So source and sink, and we could have a matrix of source and sink, then we can achieve the circularity in our resources. And unless otherwise we will not be doing, how we can meet the challenges which is coming up in 2050? We cannot. So the source and sink concept should be accepted and should be followed in our policy making, not only at government level, but in industry level also. So one industry should cooperate with other industry, providing the options of using these kind of materials. Only then all industry, including the construction industry, will grow and can provide and can meet the challenges of 2050. So now this PSC making, now the composition of composite slag, as I said, 8% and 15%, and 50% and 60% replacement of that kind of composite cement, and based on this, up to 9%, LD slag can be used in PSC making. PSC means Portland slag cement. So now recommendation from the industry that combined composite slag, means BF slag plus LD slag, should have at least 85%, which is being recommended for that. And specifically LD slag, it should have more than 40% of the amorphous content. Now we visited the LD slag plant at JSW, of course, to see what can be done with the LD slag. So we visited that plant, and how we discussed how this plant can be modified for producing the sand using the LD slag. And after discussion, we took up a research study, how it will be. So processed LD slag as a fine aggregate was evaluated for different physical, chemical, and mineralogical compositions also. Whatever has been laid down for another type of aggregate in IS 383, then mineralogical composition, as I said, was analyzed also. And the problem with the LD slag is the dimensional stability. Dimensional stability can be of three types. One is related with the alkali silica reaction. Another can be shrinkage, drying shrinkage, and all that. And third type of is the expansion. So the first kind of alkali silica reaction was also studied. The volumetric expansion studies for evaluation of potential expansion due to the presence of free lime and magnesia. in the LD slag as per modified methodology. So we have, so right now in IS 383 in appendix, if you will see, there is a method which had been taken from the Japanese standard perhaps at that point of time, that is available for the coarse aggregate only. So that method, some modifications we have been able to do that in the test method for evaluating the expansion study. So based on the modified methodology, we are evaluating the expansion of this LD slag. And in initial study, we have found that expansion is more than the conventional aggregate, and significantly it is more than the conventional aggregate. Okay? But the positive thing is, all the durability problem, no durability problem has been observed using this kind of aggregate. Now, mechanical property. Mechanical properties are 5 to 10% even better than the conventional aggregate, if the LD slag aggregate has been used. So, the most important is how to deal with the expansion. How to deal with the expansion. And why the fine aggregate is, because the coarse aggregate will be having core which will not be exposed for the weathering. So exhausting the lime available in the core will be a little bit difficult in comparison to the fine aggregate, which is a smaller size. So aging, we know how the aging can look like and how it can expand. And why this is? Because we can see from the LD slag graph, free lime is in the sample which has been analyzed, 4.5%. So the recommendation is, as I said, the durability and the mechanical properties is good in comparison to even the conventional aggregate, but the volumetric expansion study shows that expansion in the case of LD slag fine aggregate is in excess of 3% with the aggregate which has been chosen for the study, and suitable weathering methodology can be adopted to bring it down, and to ascertain the values of maximum permissible volume expansion, further studies is needed. So a broad objective of follow-up study which is being taken up with the JSW is determination of maximum permissible free lime and magnesia content in the LD slag based in the fine aggregate. So what should be the maximum permissible limit? And how it will be decided? It will be decided the corresponding free lime and magnesia, and correspondingly evaluating the expansion in a physical property. So chemical and mineralogical property and its correspondence in the physical property in terms of expansion. So the limit on both the region and the performance physically which is being observed. Now the second is the formulation of test methodology. So test methodology, without having test methodology, one speaker was saying the expansion was this percent, expansion was this percent. I was about to ask what is the methodology which has been adopted for the expansion, but I could not ask for any reason. So then the second objective is what should be the test methodology. Then third objective is determination of maximum permissible volume expansion of LD slag based. But it will not be here again, the people will not accept it. Then correlation of expansion of that volumetric expansion in aggregate should have a correspondence in the concrete also. So without having a concrete, we cannot do. And then the percentage of addition, if we can have some percentage of LD slag, as right now it is for the BF slag, that can be a starting point. And that can, based on the further research, we can go up to 100% in future. So somewhere we have to start, and to start with the LD slag as a fine aggregate, all these objectives will have to be fulfilled based on research. And we are taking up, we are under discussion with the JSW, perhaps they will be kind enough to be associated with us. Okay. So we visited the plant of ArcelorMittal to see their EAF slag and Konark slag. So it is the same kind. Some percentage has only been allowed in the present IS 383 code, and without a standard, whatever experiments we are doing in our laboratory, that will not be work. we can participate in this kind of conference, we can discuss, but nothing will happen on the ground. So standards, as SMR Prasad said, a standard is must. So to have enhanced utilization of this kind of aggregate, so ArcelorMittal approached us and we visited their plant and we collected the representative samples in our presence, and we are studying this type of aggregate at various percentages. And some studies has been completed, but particularly mechanical and durability properties. And based on this kind of aggregate can also be used up to 100%. Only a little bit apprehension of the construction community is this kind of aggregate has a specific gravity in the range of 3 or 3.2. So whether it is LD slag or it's a EAF slag or this Konark slag, so having a specific gravity more than this 2.5 in the range of 3.2 will increase the weight of any structure. And increasing the weight of a standard, we know as a structural designer, higher the weight, higher will be the lateral load, because some percentage of lateral load, some percentage of vertical load is a part of lateral load in earthquake when the earth is shaking. Because of the inertia, some part of it is a lateral load. So this kind of concrete, when it will be made a building, this will attract a little bit greater load, earthquake load. But that will not be a much. So it's near about 25%, even if to 25%, some percentage of 25%, it will come or only about 6-7%. So having 6-7% of more load, we can very well adjust with a little bit increase in the reinforcement, which will again be produced by the steel. Okay, so just we are completing it. So ferrochrome slag is a fine aggregate, just we have evaluated and we have given our recommendation. It's up to the Tata Steel again to approach to the BIS. And we are also studying the ferrochrome slag as a coarse aggregate, of course, with Vedanta. And this study is under process. Next. So my last slide is, so treat iron and steel slag, and not only this, allied industry slag also, as a byproduct, not as a byproduct, but as a co-product. So if we are adding some value, it's a value-added product. Include slag as an aggregate for infrastructure and construction activities, particularly those slag which could not be used as a mineral admixture, particularly. And include the slag in standards and regulation. BIS has already initiated process, but agenda is long, requiring support, data, study, report, and R&D. And finally, identify the collaborative research opportunity to identify areas where different quantity and quality of slag can be used. So, thank you very much. These are some papers, some research papers which has been published based on all this in this area in the international journal, and some of them has been submitted. One of them is PSC, submitted in ACI journal, in which the Tata Steel is also co-authors. So thank you very much from my side. Thank you very much.